Hi there, and welcome to today's class. For today, we'll be discussing about an important concept when it comes to calculus called integration by parts. So, integration by parts is a method of solving integration, right? When it comes to integration by parts, it's simply a method that is used to solve integration. As you can see, let's discuss integration by parts. When it comes to integration by parts, here is what you need to note. When it comes to integration by parts, if I'm given an integration to perform an integration of two functions, let's say I'm given an integration of two terms multiplying. In that concept there, I will apply integration by parts. Integration by parts is adopted or perhaps is used in integration when two terms are multiplying. That's the concept, right? So let's say given a function u of x, given two functions u of x and v of x such that they are multiplying u dot v. Given two functions u of x and v of x such that they are multiplying, hence recall from product rule, recall from product rule that says that is equal to v du over dx positive u dv over dx, right? I'm having d of the x of these two functions multiplying to be equal to v du over dx positive u dv over dx. I'm trying to derive the formula for solving integration by parts. When it comes to integration by parts, there's a formula used in our solvings, so which I'm going to derive here now. At this point here, multiply through by the x. By the x. It means that from here I'll have that the x multiplies d of u dot v all over the x. I have this to be equal to the x here multiply v du over dx, right? I'm done with this. This is a plus sign. Next up, the x into u dv over dx. I have this. At this point here, the s cancel out the x, the s cancel out the x here, the s cancel out the x here. I'll be left with d of u dot v is equal to v du, next up, plus u dv at this point here. All right, at this point here, integrate through. Integrating through. If I integrate through, I'll have the integral of du dot v to be equal to the integral of v du plus the integral of u dv At this point here, recall something from what we know generally. If I integrate dy, I'll have y. If I integrate the x, I'll have x. The condition here is that the tax here, or perhaps the logic here is that if I integrate something, or perhaps if I integrate the y, the idea is that integration cancel out d, left with y. If I integrate the x, integration cancel out d, left with what? X. So it means that if I integrate d of everything here, it means that this and this will cancel out, left with what? U dot v. I'll have u dot v left to be equal to the integral of v du positive the integral of u dv. At this point here, I'll take this one here to left hand side. So I'll be having u dot v to be u dot v. When this one comes, it becomes minus integral of v du to be equal to integral of u dv. At this point here, I'll do some rearranging. So pick out this one first. I'll have the integral of u dv to be equal to u dot v minus the integral of v du. This is the formula for calculating problems under integration by parts, that the integral of v du of u dv is equal to uv minus the integral of v du. This is how to derive the formula for calculating integration by parts. All right, let's take some problem and further explain how this technique work under integration. All right, example one. If I'm told to evaluate the integral of s cos x dx, I'm told to perform the integration of x cos x with respect to the x. What do you do? For this case here, or for this integration here, I'm seeing two terms multiplying. So I'm seeing x multiplying cos x. So it means that I'm having two terms multiplying such that, let's say the two terms are u and v multiplying. I'll apply integration by parts. So I'm having x and cos x multiplying. So I'll apply the concept of integration by parts to this concept here. So this means that my task now is to recall our formula for calculating integration by parts. Recall that we said when it comes to integration by parts, the formula becomes the integral of u dv to be equal to u dot v minus the integral of v du. At this point here, recall this formula. Now, what next? Your next task is to compare your question with this one here. So pick out this one first. I have the integral of s cos x dx. Compare with this to be equal to the integral of u dv. Observe, please. Compare this question here with this one here. It means that my u will be x, my dv will be cos x. So when it comes to integration by part, I need to know u and the u. I need to know v and the v. That's the concept. When it comes to integration by part, you are looking for 4 parameters. You need to know u. You need to know the u. You need to know v. You need to know the v. That's the concept. There are 4 parameters you are looking for. So now I've gotten my u. What's u? Compare them. U is equal to x. dv is equal to cos x. That's the concept. So at this point here, u is equal to cos x. Now we know that we said we are looking for u and what? Du. So it means that I've seen u to be equal to cos x. If I want to get du, what will I do? I will differentiate this one here. If I differentiate cos x, I'll have what there? Minus sine x from differentiation. Differentiate cos x, I have minus sine x. I've gotten the value for u and du. All right, we also said dv is equal to what? Cos x. So dv is equal to cos x. Now, to get v, I said I need u and du, which I've gotten here. I also need v and dv. So I'm given the v. To get v, what will you do there? So to get v, what will you do? Observe something, please. I'm having du. Du was derived from what? Differentiation. So I'm having dv. This is differentiation. To get to v, I what? Integrate. So if I integrate cos x, I'll have what there? I'll have sine x. Integrate cos x, I'll have sine x. So it means that let's say I'm given v to be equal to sine x. To get the v, I'll differentiate. When I do sine x, I'll have what the cos x. That's why we said integration is the reverse of differentiation. That's the concept. So I've gotten my parameter here. Let's get value, please. It means that the integral of u dv, which is equal to u dot v minus the integral of v du, is now equal in value to look up please, is now equal in value to what's u? Or perhaps we said u is what? Cos x. I'll have the integral of cos hang on hang on observe please, I said comparing please. It means that u is equals to x, the v is equal to what? Cos x. That's the concept. So u is x, please. So have x here, not cos x, please. U is x. Then du be what? If I differentiate x, I'll have what there? I'll have 1. That's the concept, please. Please compare, please. I made a mistake. U is x, dv is cos x, please. So dv is cos x as I have here. I'm correct here. So it means that look up please. It means that the integral of u is x, Abi. The integral of x cos x, that is the v, is cos x, as we said here. So the integral of this one here, which is respect to the x, which is the question, that is, if I integrate this question here, it will be equal in value to u. What's u? X multiply v. What's v? V is sine x. As in this case, I'm done with this one here. This is minus the integral of v. What's v? That's sine x. I have sine x. Next up, du. What's the u? That's 1. I have 1 at this point here. To proceed with my solving, if I integrate this function here, I'll have that x times sine x is x sine x minus the integral of sine x times 1 is what? Sine x. I'm still left with integration here. To simplify more better, I'll have x sine x minus, if I integrate sine x, I'll have what there? Minus cos x. If I integrate sine x, I'll have minus cos x. Then stop, plus c. It means that x sine x minus will give plus cos x plus c as my answer after integrating x cos x related to the x. This is my answer here, as you can see. So the concept here is that you are comparing. Pick out the question and compare with this form here, this formula at this part here. The formula at the left hand side, which is this one here. So it means that u is x, the u is cos x. So put them this way, and so if I'm having u to be x, to get the u, I will differentiate. If I'm having the v to be something, to get v, integrate that function. You have this one here. So those are to solve problem under integration by part, please. All right. See you in the next class.